Okay, to simplify this rational expression, the first thing you have to do is you have to factor out whatever is common to both the numerator and denominator. So what we're going to do is we're going to factor the numerator, and we see that 5 and x can both come out of the numerator terms. So we have 5x times x minus 3 all over. And I'm going to factor this one, even though 10x squared you probably wouldn't have to, but this is 5x times 2x. Now it might make it seem like I made this a little more complicated, but just to show you that these do have common factors. Now that I've factored these out, I can cancel them out into each other, and I'm just left with x minus 3 all over 2x. Okay, here is an example where you have a trinomial on the numerator, a trinomial on the denominator. In this particular case, you want to get this factored, and since it's a quadratic with a linear term and a constant term, you're going to think about the product of two binomials. So we're going to factor the numerator into x and 6 and 1. And since this is positive, I know they have to both be positive or both be negative. Now 6 and 1 in this particular case are not going to work, because if I have a 1 here and a 6 here and they have to both be positive, I'm going to end up with 7 here, and I don't want that. So I have to change that to 2 times 3, which also gives me 6, but now 2 plus 3 gives me the 5. And since the middle term is negative, that means they're both negative. This will give me the positive 6 I need here and the negative 5 here. Now in the denominator, I'm going to do the same thing, and we put x and x. Two numbers when multiplied together give us 12, whose sum, because it's positive, is going to be 7. So 4 times 3 gives me 12, and if they're both negative, because my middle term is negative, I'll get the negative 7. Now, I notice that I have the same binomial on the numerator and denominator, so this can cancel out into here once and into here once, and I'm left with x minus 2 all over x minus 4. Now, you might think that you can cancel the 2 into the 4, but you cannot here because this is subtraction. So remember that. That's one case where you can't factor that out. Sometimes when you're given these in rational function notation, this is a rational function, g is a rational function, we can say, and when you're given these, you want to simplify these. You also want to do what the book asks you to do, is find the zeros and find the domain. Now the domain is anything that does not make the denominator 0. Well, the first step in these is to factor them, because we have to factor the numerator and the denominator because we need to know both. And I'll explain that. Now the denominator factored, let's just concentrate on that for the domain, is t times t squared minus 4. And then this part right here is the difference of two perfect squares, so I can refactor that into t plus 2 times t minus 2. Now my domain is the set of reals minus anything that makes this equal to 0. Well, here we have t equals 0 would make the denominator 0, t equal to negative 2 makes the denominator equal 0, and t equal to 2 makes the denominator equal to 0. So my domain, then, is the set of reals minus the set containing 0, negative 2, and 2. Now when I factor the numerator, because I care about the numerator when I want to find the zeros, the numerator is going to be factored also like this. Now nothing goes into 3, 9, and 2, so I'm left with that beginning coefficient of 2, so I have 2t times t, and if I put 3 and 3 I get my 9, and I'll get 3t here and 6t, which the difference of those will be 3t. My largest one I want to be positive, and that would be the 6t and minus the 3t. Now where this is equal to 0, okay, is the zeros of the function. In other words, it will cross, if this were an x and y, this would cross the x-axis. If we plotted it, this graph would cross at these 2 points. So now what we do is we set the 2t minus 3 equal to 0 and t plus 3 equal to 0. Here we have t equal to 3 halves and t equals negative 3. These are the 2 zeros of this rational function. If you wanted to put them in point notation as points, and if this were an x and y, this would be your x value, so it would be 3 halves, your abscissa, and your ordinate would be 0, or negative 3, 0, and those would be the zeros. Otherwise, you could just leave it like this if they just ask for zeros and it's not an x and y.